Embark on an enthralling journey to a world long vanished, yet crucially intertwined with our own.
Now, a remarkable scientific discovery has been made in China. Researchers say they found the skull of what they believe is a new species of human, which could be our closest evolutionary relative.
In the annals of prehistory, enigmatic figures lurk, their stories etched in stone and bone. These are the tales of the most mysterious extinct human species, relatives lost in the mists of time, yet fundamental to our story. Ready to meet them? Number 1. Homo habilis, the handyman. Homo habilis, affectionately known as the handyman, marked a pivotal chapter in the human evolutionary saga. Unearthed in the 1960s by Lewis and Mary Leakey in Tanzania's Olduvai Gorge, these early humans were a breakthrough discovery, dating back to about 2.4 to 1.4 million years ago. Homo habilis stood out in the hominin family tree for their unique characteristics. Unlike their more ape-like predecessors, Homo habilis displayed a fascinating mix of traits. They possessed longer arms suited for climbing, but also had hands capable of precise grip, ideal for tool-making. This was a game-changer. For the first time in our evolutionary history, we see evidence of manufactured tools, simple yet revolutionary. The stone tools, named Oldowan after their discovery site, were primarily used for cutting and scraping. Imagine the moment the first sharp-edged rock was picked up. It wasn't just a tool, it was the dawn of a new era. Their brain size, averaging about 610 cubic centimeters, was significantly larger than earlier hominins, suggesting an increase in cognitive abilities. This growth in brain power, combined with tool use, possibly played a crucial role in their survival strategies. But what about their daily lives? Homo habilis likely consumed a varied diet, including meat, which was somewhat of a novelty at the time. This shift towards a more energy-rich diet might have supported their larger brains. Homo habilis also shared the landscape with other hominins, including the robust Paranthropus. This period was no walk in the park. Survival was a daily challenge. Predators lurked, climates fluctuated, and resources were a constant pursuit. Number 2. Homo erectus, the wanderer. Homo erectus, known as the wanderer, emerged around 2 million years ago and marks a significant evolution in our human story. This species was not just a local player. They were the first of our ancestors to step out of the African cradle and spread across Eurasia, a feat that earned them their nickname. What set Homo erectus apart? For starters, their physique was more aligned with modern humans. They had longer legs and shorter arms, a build suitable for long-distance walking and running. This physical adaptation was crucial for life outside the lush African environment, enabling them to traverse vast and varied landscapes. But their wanderlust wasn't just driven by legs made for walking, it was also fueled by an intellectual leap. Homo erectus is credited with developing the Acheulean tool culture, marked by hand axes and cleavers. These tools were not just sharper and more sophisticated than the Oldowan tools of their predecessors, they were symbols of a cognitive revolution. Their brain size, averaging around 900 cubic centimeters, was significantly larger than Homo habilis. This increase in brain volume hints at more complex social structures and perhaps even the early sparks of what we would recognize as culture. Their diet, too, diversified. Evidence suggests they were skilled hunters and gatherers, capable of exploiting a range of environments. Number 3. Homo heidelbergensis, the ancestral link. Homo heidelbergensis, the ancestral link, lived approximately 600,000 to 200,000 years ago. They are a crucial puzzle piece in our evolutionary history, believed to be the common ancestor of both Neanderthals and modern humans. This species represents a bridge between the primitive features of early hominins and the more complex traits associated with later species. Discovered first near Heidelberg, Germany, Homo heidelbergensis exhibited significant advancements over their predecessors. They were robust and tall, with a heavy brow ridge and a larger brain case, averaging about 1,200 cubic centimeters. This increase in brain size suggests advanced thinking and problem-solving abilities. One of the most remarkable aspects of Homo heidelbergensis was their technological innovation. They created sophisticated tools, including wooden spears, the oldest known wooden artifacts. These spears, along with evidence of large game hunting, indicate a strategic approach to survival, involving planning, cooperation, and perhaps even communication skills akin to language. Moreover, Homo heidelbergensis may have been the first to build shelters, indicating a shift towards a more sedentary lifestyle and complex social structures. There's also evidence suggesting they controlled fire, a skill that would have provided warmth, protection, and new ways to process food. Number 4. Neanderthals, the misunderstood cousins. Neanderthals, our closest extinct human relatives, have long been enshrouded in mystery and misconception. Living from around 400,000 to 40,000 years ago, primarily in Europe and Southwest Asia, they have often been portrayed as brutish and primitive. However, recent discoveries paint a far more nuanced picture. Physically, Neanderthals were robust, with a stocky build, adapted to the cold climates of the Ice Age. Their physical prowess was evident, but it's their cognitive abilities that have sparked a reassessment. Their brain size was comparable to ours, suggesting a high level of intelligence. One of the most fascinating aspects of Neanderthals is their culture. They created complex stone tools and weapons, including the sophisticated Mousterian tool culture. Archaeological evidence shows they were skilled hunters, adept at taking down large prey, a task requiring cooperation and strategic planning. But there's more to Neanderthals than hunting. They used pigments, possibly for body painting or artwork, indicating a sense of aesthetics. They also buried their dead, which some scholars interpret as evidence of ritualistic behavior and possibly spiritual beliefs. The revelation of interbreeding between Neanderthals and modern humans has further transformed our understanding. Many people today carry Neanderthal DNA, a testament to this ancient interaction. It suggests that the relationship between our species was more complex and perhaps even amicable. Number 5. Denisovans, the mysterious Siberians. The Denisovans, an enigmatic group of ancient humans, came into the spotlight with the discovery of a tiny finger bone and a few teeth in Siberia's Denisova cave in 2010. These scant remains have unveiled a fascinating chapter in human evolution, one that stretches our understanding of ancient human diversity. Much of what we know about the Denisovans comes from genetic analysis, as their fossil record is currently sparse. They lived around the same time as Neanderthals, possibly from 200,000 to 50,000 years ago, and shared a common ancestor with them. The real intrigue lies in their widespread genetic impact, found in the DNA of modern humans, particularly among populations in Asia and Oceania. The Denisovans are believed to have been well adapted to high-altitude environments, as suggested by a specific gene variant found in the modern Tibetan population, enhancing their ability to thrive in low oxygen conditions. This genetic adaptation is a direct inheritance from Denisovan ancestry. Their technological culture remains largely a mystery. However, the discovery of a Denisovan bracelet in the cave, made of polished green stone and showing signs of sophisticated tool use, suggests they were not primitive. This artifact hints at a level of cultural complexity not previously associated with them. The interbreeding between Denisovans, Neanderthals, and modern humans highlights a complex web of interaction among ancient human species. It challenges the notion of clear-cut species boundaries in human evolution. Number 6. Homo floresiensis, the Hobbit. Homo floresiensis, affectionately dubbed the Hobbit due to their small stature, is one of the most astonishing discoveries in paleoanthropology. Unearthed in 2003 in the Liang Bua cave on the Indonesian island of Flores, these diminutive beings challenge our understanding of human evolution. Living as recently as 50,000 years ago, their existence overlapped with modern humans. What sets Homo floresiensis apart is their size. Adults stood about 3.5 feet tall, with a remarkably small brain size of around 400 cubic centimeters, akin to that of a chimpanzee. Yet their stone tools, evidence of hunting and use of fire, suggest a level of intelligence that defies their small brain size. The origin of Homo floresiensis is a topic of intense debate. Some scientists propose they descended from Homo erectus, shrinking in size over thousands of years through a process known as island dwarfism, a well-documented phenomenon where species become smaller when resources are limited. Others suggest they might represent an older, more primitive lineage of hominins. Their diminutive form raises fascinating questions about human diversity in the Pleistocene. How did they survive and thrive on Flores? Did they interact with modern humans? The answers remain elusive, buried in the layers of prehistory. Number 7. Homo luzonensis, the recent surprise. Homo luzonensis, a species announced to the world in 2019, quickly became one of the most intriguing puzzles in human evolution. Discovered in the Callao Cave on the Philippine island of Luzon, this species is known from a handful of teeth and bones dating back to 50,000 to 67,000 years ago. Their discovery in Southeast Asia adds a new dimension to our understanding of hominin diversity. Characterized by a mix of primitive and advanced features, Homo luzonensis challenges the straightforward narrative of human evolution. They had small teeth like modern humans, but their fingers and toes bore similarities to ancient hominins like Australopithecus. This combination suggests a complex evolutionary history that might involve isolated pockets of hominins evolving unique traits. One of the most striking aspects of Homo luzonensis is their isolated location. Luzon has been an island for millions of years, raising questions about how and when these hominins arrived there. Did they cross the sea intentionally, or were they castaways from accidental voyages? The physical attributes of Homo luzonensis, particularly their foot bones, suggest they were adept at climbing, a trait that would have been beneficial in the forested environment of ancient Luzon. Their ability to adapt to this unique habitat speaks to the incredible versatility of the hominin lineage. Number 8. Homo naledi, the star of the underground. Homo naledi, discovered in 2013 in the Rising Star Cave system in South Africa, is a remarkable addition to our human family tree. The discovery, made in a chamber accessible only through a narrow underground chute, unveiled a trove of fossils, over 1,500 bones belonging to at least 15 individuals, ranging from infants to elderly adults. This find provides an unprecedented glimpse into an ancient hominin species that lived between 236,000 and 335,000 years ago. Homo naledi stood about 4.5 to 5 feet tall and had a peculiar mix of primitive and modern traits. Their skull was small, with a brain size comparable to Australopithecines, yet their hands and feet were strikingly similar to modern humans. These features suggest a complex evolutionary background, blurring the lines between different hominin species. What's truly groundbreaking about Homo naledi is the context of their discovery. The Dinaledi chamber, where the bones were found, appears to have been a deliberate burial site. This behavior, previously thought to be unique to Homo sapiens, suggests that ritualistic body disposal and possibly some conception of an afterlife might have been present in Homo naledi. The discovery of Homo naledi challenges many established ideas about human evolution. Their existence alongside early modern humans implies a rich diversity of hominin species in Africa during the late Pleistocene. It also raises questions about the spread of cultural and intellectual traits, previously thought to be exclusive to our species. Number 9. Homo longi, the Dragon Man. Homo longi, nicknamed Dragon Man due to the Harbin cranium's discovery near the Dragon River in China, is a relatively new addition to the human family tree, described in 2021. The cranium, which is remarkably well preserved, dates back to at least 146,000 years, placing it in the Middle Pleistocene era. This discovery is significant as it may represent one of the closest relatives to modern Homo sapiens, potentially reshaping our understanding of human evolution in Eurasia. The Harbin cranium boasts a unique combination of features. It has a large brain case, broad face, and square eye sockets, yet lacks a modern human-like chin. Its massive size and robustness set it apart from other contemporary hominins, including Neanderthals. The physical characteristics of Homo longi suggest a species well adapted to its harsh, cold environment. One of the most intriguing aspects of Homo longi is its potential impact on the human evolutionary tree. Some researchers propose that Homo longi might be closely related to, or even part of, the Denisovan lineage, the elusive relatives of Neanderthals known mostly from their genetic legacy in modern humans. This hypothesis is based on both the geographical proximity and the time period in which Homo longi lived. The discovery of Homo longi challenges the predominantly Africa-centered narrative of human evolution. It suggests a more complex picture, with multiple human species coexisting and interacting in Eurasia. The exact relationship of Homo longi to both Homo sapiens and Neanderthals is still a matter of active research and debate. Number 10. The Red Deer Cave People. The Red Deer Cave People represent one of the most recent and intriguing puzzles in human evolution. Discovered in the Red Deer Cave and Longling Cave in China, these remains, dating to as recent as 11,000 to 14,000 years ago, challenge our understanding of the diversity and timeline of human species. This discovery is significant because it suggests that there were more human lineages coexisting in Asia alongside modern humans than previously thought. The physical characteristics of the Red Deer Cave people blend archaic and modern traits. They had a prominent brow ridge and thick skull walls, reminiscent of ancient hominins. However, their frontal bone and brain case bear a closer resemblance to modern humans. This mix indicates a complex evolutionary history, possibly representing a late surviving group of an unknown hominin species. What sets the Red Deer Cave people apart is their unique cultural context. The evidence of cooked large mammal bones, including red deer, in the caves suggests they were skilled hunters and gatherers, adapting effectively to their environment. This adaptability is crucial for understanding how different human species managed to survive and interact in the changing landscapes of the Pleistocene. The debate about their exact place in the human family tree continues. Are they a new species, a regional variant of Homo sapiens, or a relic population of a more ancient lineage? Their recent coexistence with modern humans raises questions about possible interactions and cultural exchanges between different human groups. Number 11. Homo rhodesiensis, the Broken Hill Skull. Homo rhodesiensis, often known for the iconic Broken Hill skull discovered in 1921 in northern Rhodesia, now Zambia, is a fascinating yet enigmatic chapter in human evolution. Dating back to approximately 300,000 to 125,000 years ago, this species represents a key phase in the development of archaic humans in Africa. The Broken Hill skull is characterized by a combination of archaic and modern features. It has a large face, prominent brow ridges, and a massive brain case, similar to Neanderthals. However, the skull also shows traits that are more aligned with modern Homo sapiens, such as a more rounded cranium. This mosaic of features suggests Homo rhodesiensis was a transitional form, bridging earlier human ancestors and modern humans. Homo rhodesiensis lived in a period of significant environmental change, which likely influenced their adaptation and survival strategies. The archaeological evidence associated with them, including stone tools and evidence of hunting large mammals, indicates a sophisticated level of tool use and social organization. Their physical build, characterized by robustness and a large cranial capacity, averaging around 1,300 cubic centimeters, suggests they were well adapted to their environment, capable of enduring the physical demands of their landscape. The exact relationship of Homo rhodesiensis to both modern humans and Neanderthals is a subject of ongoing debate among paleoanthropologists. Some consider them to be a regional variant of Homo heidelbergensis, while others suggest they could be directly ancestral to modern humans, particularly in Africa. Number 12. Homo antecessor, the pioneer of Europe. Homo antecessor, often hailed as the pioneer of Europe, is a significant but somewhat controversial species in the human evolutionary narrative. First discovered in the Grandolina Cave in Atapuerca, Spain, and dating back roughly 800,000 to 1 million years ago, Homo antecessor may represent one of the earliest human species in Europe. The physical attributes of Homo antecessor blend primitive and modern traits. They had a robust build, with facial features showing a mix of traits seen in both Homo erectus and later human species. Their teeth, in particular, show a unique pattern that sets them apart from other hominins. This combination of features suggests they were an evolutionary bridge between earlier and later human species. One of the most intriguing aspects of Homo antecessor is the evidence of their behavior. The discovery of butchered animal bones alongside human remains at the Grandolina site indicates that they were skilled hunters. More controversially, some of the human bones show cut marks, leading to speculation about cannibalistic practices, although this remains a topic of debate. Homo antecessors' role in human evolution is still under discussion. Some researchers propose they were a common ancestor of both Neanderthals and modern humans, while others suggest they were a separate offshoot of the human family tree, leaving no direct descendants. Number 13. Homo rudolfensis, the controversial one. Homo rudolfensis, known as the controversial one, is a subject of intense debate among paleoanthropologists. Discovered in 1972 near Lake Rudolph, now Lake Turkana, in Kenya, this species is dated to about 1.9 million years ago and presents a unique set of features that distinguish it from contemporary hominins. The primary source of controversy is the classification of Homo rudolfensis. With its large brain case, flat face, and large molars, Homo rudolfensis does not neatly fit into the established categories of early human species. The skull, known as KNMER 1470, is markedly different from Homo habilis, which lived around the same time. These differences have led to debates about whether they represent separate species or variations within a single species. Homo rudolfensis's facial structure and brain size, which is significantly larger than Homo habilis, suggest advanced cognitive abilities. However, due to the limited number of fossils attributed to this species, much about their lifestyle, culture, and abilities remains unknown. Their ecological niche and dietary habits are inferred from their physical traits. The large molars and robust jaw suggest a diet that included hard or tough plant materials, although they likely had a versatile diet typical of early hominins. Homo rudolfensis's place in human evolution is intriguing. Some researchers see them as a distinct branch of the early human family tree, potentially ancestral to later species. Others argue that the variation in their features is within the range of what's seen in other hominin species, suggesting a single, highly variable species. Number 14. Homo helmai, the recent ancestor. Homo helmai, often regarded as the recent ancestor, represents a fascinating but lesser-known chapter in human evolution. This term was initially proposed to categorize a set of African human fossils that seemed to bridge the gap between Homo sapiens and archaic human species. These fossils, dating back to approximately 300,000 to 200,000 years ago, provide insights into the complex transition towards modern humans. The key characteristics of Homo helmai include a mix of archaic and modern features. They had a large brain case, similar to modern humans, but retained some primitive traits in their skulls and teeth. This combination suggests they were on the cusp of the evolutionary transition to Homo sapiens. What makes Homo helmai particularly intriguing is their temporal and geographical positioning. They appear at a critical juncture in human evolution, at a time when modern human features were beginning to crystallize. Their presence in Africa, widely considered the cradle of humankind, underscores their potential role as a transitional species or a regional variant of early Homo sapiens. The discussion around Homo helmai touches on broader themes in paleoanthropology, such as the nature of species delineation and the fluidity of human evolution. They highlight the gradual and mosaic nature of evolutionary change, where species boundaries are not always clear-cut. Number 15. The unknown others. Uncharted territories. The story of human evolution is not just about the species we know, but also about the unknown others, potential human species that remain undiscovered or poorly understood. These uncharted territories of our evolutionary past remind us that what we know is just a fraction of the rich tapestry of human history. Throughout Africa, Asia, and Europe, there are tantalizing hints of other hominins that lived alongside and possibly interacted with known species. Isolated teeth, fragmentary skulls, and ambiguous tool cultures suggest the existence of these enigmatic human relatives. Their elusive nature raises questions about the diversity and complexity of the human lineage. Advancements in technology, such as DNA analysis and sophisticated dating methods, have the potential to uncover these unknown chapters. The discovery of the Denisovans, for instance, was made possible through genetic analysis, even though their physical remains are scarce. Similarly, ongoing excavations and research may reveal more about these hidden figures in our evolutionary story. The possibility of undiscovered human species also challenges our understanding of human migration, adaptation, and interaction. How did these species survive in different environments? What was their cultural and technological level? How did they interact with contemporary human species? These are some of the questions that keep the field of paleoanthropology dynamic and exciting. The exploration of these uncharted territories is not just a scientific endeavor. It's a journey into the origins of humanity. Each new discovery adds a piece to the puzzle of our shared past, illuminating the diverse paths our ancestors took in their journey to the present.